Hi there, welcome to my channel. And in this video, we are going to solve this interview problem. And the problem is to remove duplicates from sorted array. And this is the problem statement. We are given with an integer array, which is in a sorted order, and we have to remove duplicates with in-place operation, such as its unique element appears only once. So whatever operation we are doing, it should be in place. That means we should not consume any more memory space, or we don't have to create one more array. Whatever operation we are doing, we have to do inside this array. And at the end of the program, we have to return the length of the final array after removing a duplicates element. And it is also saying that do not allocate any extra space for any another array. All the modification should be in place with order of one extra memory. And example is given here. We have input 112, and we are getting output as 2 after removing duplicate. So the final output array is 1, 2, and the rest of the elements could be anything. It could be either blank or could be some garbage value. That doesn't matter. Okay, now let's see how to what would be the approach for this one. So we are given with an array, and here we have an example, and this is the array. So there could be a various approach to solve this problem. The first would be like you could use some kind of data structure to solve this problem. We could go with map data structure. In JavaScript, we could go with map or object. So here we have a key value pair, and what we can do, we can put these values as a key here in the map, and in the value section we can put any count 0, 1, 2, any count occurrence of that element in this array. And the next time when another elements come which is already there in map, it won't create a new entry, it will refer to a same entry. So while iterating through array, we'll get two element 1 and a 2 with their count, and we can get all the keys from this map, and that would be unique. So this is one approach. Second would be we could use set data structure, where we can convert our array to set, and set by nature it contains only unique element. So if you directly convert your array to set, you will end up with only 2 values. But the problem with this 2 approach is you have to use some extra space. If you're going with a map, you have to create a map and you have to store in the memory. Similarly, if you're going with set data structure, you have to create and store it in memory. But as per the question, we have to do everything in place. So here comes our third approach. Let me remove all this. Yeah. So the third approach would be two-pointer technique. So whenever you see a question like this, where you have a sorted array and you have to do some kind of searching, in that case, always try to go with two-pointer technique. The benefit of it is you will solve your problem in order of n time complexity. So let's see how two-pointer technique will work. So let's take 2 pointers, P and Q. So the P item will be pointing to the first position, Q will be pointing to the next one, just next to P. So what we are going to do, so here the main purpose is to remove duplicacy. So we'll maintain 2 pointer. The pointer P will be pointing to unique elements, and the Q, we will use this to bypass the duplicate elements. So while doing this operation, we'll end up with these 2 cases: what to do when we have equal case and what to do when we have not equal case. So equal case is like this: if the element which is pointed by P and Q both are equal, then what to do? In that case, we simply want to increment Q to the next position. So Q we are using to bypass. So simply we'll increment it to the next element. So in this case, we'll just increment the Q value. And what to do in case of not equal to? Let's see that. Yeah. So right now P is pointing to first, Q is pointing to second. Not equal to case will arise here if Q is pointing here. So here these 2 are not equal. These 2 values are not equal. So it will go. It will fulfill this condition, and this will only happen if the previous element which was pointed by P, the element which is pointed by P and Q, if it's not equal. So here what we want to do, here we want to increment the P value so that it goes to the next position, because the first position is already filled with a unique element. So we'll go to the next place where we want to fill a next unique element. So we'll just increment the P value so that we'll position it correctly. And the next thing is, right now Q is pointing to this index, and now p is pointing here. So what we'll do, we'll just put this value to this place. So what we'll do, we'll just put, let's call this array nums. So in the pth position, we'll just put whatever we have in queue. So now what will happen? This one will go off, 2 will come here. Yeah, and after that we have to increment q value as well, because now we have 2 here, 2 here. So right now we don't have anything, but at the end we have to increment q value also. So this is the concept. Now let's see this in action. Let's write a program for it. So I'm going to write a simple JavaScript code. So let's write a function. Let's call it remove duplicate, and we have an array with us. And the first thing is, we'll have 2 pointer. First with the index 0. Second, let's point it to next one, and we'll iterate through each element of an array with this condition. Yeah. After that, we'll check for those 2 conditions. If nums of p, if it is not equal to nums of q, then if it is not equal to, then we are going to increment p position, and we are going to put the value of q to p. Yeah, so this is done. And after this, so we had 2 conditions, equal to and not equal to, and in both of the cases we were incrementing. So this was the common code, so I put it outside, and here ends the while loop. And at the end, we have to return the length of our final array. So if you see here, if you see here at the end, we'll end up with this element 1, 2, and 2, where p will be pointing to this particular location and q will be pointing to this location. And if you notice, p is pointing to the final unique element which we have in the array, and the rest of the elements which we have in the array, it could be some dummy or some garbage value. So we don't have to consider others. So whatever position p is in, we have to return that position. And as per the question, we have to return the length. So here we have to make sure, here we have to make sure that we return p value, but p is an index, but we wanted it in length, so I'll do +1, and I'll close the function. Yeah, so that's it. This will cover this problem, and I hope you don't have any questions. In case you have questions, you can ask me in the comment section below. And I hope this video was useful to you. If you find it useful, please don't forget to like, share, and subscribe. And I'll see you in my next video. Thank you.